Hello and welcome. Let's be aware of each other, be friendly and patient. After all, we are all here to learn. Thank you. Today, I am very happy to welcome Matthias Oleusson, Magnus Tinner, and Sanjay Medic with us for this very live stream to present and to moderate the chat. Last week, no, 2 weeks ago, on the first episode of this two-part series, our chat was just on fire, and that was absolutely fantastic. You guys rock. I really, really hope that today is going to be the same. So we have moderators here to help you with the chat, answer questions. So keep it up. Let's just repeat what we had 2 weeks ago. In case you missed last week's or 2 weeks ago session, I will drop the link to YouTube for that session in the chat just in a minute. But now let's bring the guys here. Hello. Hi,
everyone.
welcome, and
Hi.
great to have you here again. How are you all today?
Thank you very much. I'm fine.
Yeah, great. Great to be here.
So let's kick this off and get started.
All right.
While we wait for the first slide to start, I'll give a recap. So maybe it's coming now.
Hello? Yes, I don't know what happened. Did you hear me,
Yeah.
or where are you now?
No, I think
Now-
you drop off for a couple of
Yeah.
seconds. So yeah.
Now we are at the correct slide. So let me get started.
Right.
As Rika said, last
Okay.
time we looked at the software development lifecycle and how we can automate the process using GitHub and Azure. This time we're more focusing on how to extend the process to include the security practices to limit different kinds of risk we can have by introducing vulnerabilities in the product we build and release. So today, IT security is not something we care about after the system has been released, but we need to focus on it while we build our product and processes. So there are a couple of things we will talk about today when it comes to security. We need to think about security when we write the code to avoid exposing attack services. We need to carefully assess the modules we build on solutions on as a third-party components. And we also need to continuously inspect the results of the security analysis we have. And we're going to show a little bit about that more today. But first, we will say a word about us and our company. So Sanjan, next slide, please. My name is Magnus, and I am a principal consultant at Solidify, and I'm also a Microsoft Developer Technologies MVP. Over to you, Sanjan.
Thank you so much. My name is Sanjay Medic. I'm head of development at Solidify. I'm security, really interested in security, so I'm contributing in OWASP, where I'm OWASP chapter leader for Stockholm. And Matthias?
He fell silent. Are you there, Matthias?
My turn. All right. So I'm here with the rest of the guys from Solidify. Being the CTO, I get to work with a lot of different challenges, but DevOps and engineering is kind of my field. So happy to be here. Thank you. Let's go further.
So at Solidify, we work with our customers to evolve and make their ability to create good software in an easy way. That's what we do. We work all over the Northern Europe and mostly in Scandinavia. We are around 60 employees working with helping our customers evolve using DevOps. We also have a couple of MVPs as well. So over to the agenda. We're going to talk about what is DevSecOps. Then we're going to talk about static code analysis or static code scanning using GitHub. And we're going to end the presentation with showing you dynamic security analysis using OWASP and what that is. But first, we have Matthias is going to show you a little bit about secure software development lifecycle management.
All right. I think the network is fine again, right?
I think so, yeah.
Yep.
It's always interesting. We should always accept the challenge of doing everything remote. So yeah, fingers crossed it's working. First, we just want to do a quick recap of what we talked about last time that would lead into the DevSecOps session for today. But what we have as a foundation is how we build software. So we talked last time about the importance of having a nice and consistent software development lifecycle, where you have a defined process with the steps you take from planning to system in production. And this is something we evolve and iterate over. So we get to deliver high quality software in a consistent way. And the SDLC, the software development lifecycle, that's the core of what we do in order to build the software. So it gives us the structure, it gives us guidance to join a team and continue to work in the same way that the others are doing. It helps us build software with high quality, on time, reduce risks, because we have an agreed framework to work on, and so on. So there's a lot of good stuff having a really good process, regardless if you are 2 people working together or if you are hundreds. Then this is something we have evolved over the years. So we often talk about DevOps these days. And we can move to the next slide, Sanjin. And for us, this is the evolution of the life cycle. So we take the process that we know, but we also combine them with the ways we work together and try to remove any silos between the different steps in the process. So instead of having a planning department that would do all the planning and then hand over work to the developers that hands over the result to the testers and so on, we build team that works together. So that's very much what DevOps is about. And of course, this should go nicely together with tooling. So we do this in an efficient way. Then we have the topic for today, and Sanjin will dive into this in detail to show what it means. But we extend the DevOps process, the lifecycle work that we have, with an emphasis on security practices and tools. So it's not, like Magnus said, something we do as an afterthought. This is something we build into the process. And with that, it comes that we need to think about security in all the different phases of our software development work. So from a planning perspective, we will do risk assessments. We will work with clear acceptance criteria to understand the problem that we're trying to solve. In the development phase, we do a lot of security-related work when practicing secure development or DevSecOps, meaning that we do fundamental things like ensuring and controlling how people in the team can access the code. So we don't open up for vulnerabilities because unknown people can introduce changes to the code base. And then we can practice other good practices like testing, doing code reviews, but we will also extend this with automatic security checks, and that's typically what we call code analysis. Then in the build and deploy part, or CI/CD that we talked about last time as well, we have a framework and engine to run things. So that's a perfect place to automate security checks and all sorts of scans. So we would try to automate code scanning, looking for dependency vulnerabilities, looking for secrets in our codes. And this is something we then can use to be more confident that when we're ready to ship, we have done a lot of security checks on our software. But of course, the process doesn't end there. So when we have finished building the stuff, we have deployed it, then we can continue to run security checks as well. Ensure that the infrastructure is secure, do dynamic testing on the software. And after that, we get more into the traditional IT security measurements. But from a developer perspective, we focus more on the earlier phases and security practices. So in the next slide, we'll see how this can be built out. So we have the development life cycle. We have the mindset that we will work together as a team, not in individual phases, but all together to deliver a great solution. The security practices we get trained on, we learn to work with it, but we also should choose tools that helps us do this in an efficient way. So in this picture, we put in a lot of icons from the Microsoft stack. So here we see that we can use a mix of different platforms like Azure Boards, Azure DevOps, Teams to manage part of our development work. In this case, and today we will talk a lot about the GitHub capabilities. So as we see here, when we move from planning to implementation, we have lots of places where we can use tools to do code scanning, vulnerability scanning, automate running all sorts of different types of checks. So this is something we should think about, and we should, of course, work iteratively, think about how we need to build something, think about how we can improve it by adding more capabilities, such as security. And then when we have the recipes, we should look for efficient ways to do this. So now I'm happy to hand over to you, Sanjin. You're the expert on DevSecOps in this team. So let's see what you can share about GitHub and these practices next.
Thank you so much, Matthias. All right, so to more specific details of GitHub Advanced Security. So when we look at the GitHub Advanced Security, we're trying to do a shift left, which means that we try to enable all those tooling out of the box for developers to just use, and so they don't need to think about the security in that manner. It will be served for you. And if we group it, we have two things. The first one is protecting your supply chain. And this is where we have a dependency graph. We can visualize what kind of dependency do we have. And also this is where we have advisory database, which is canonical database where we can have the dependency vulnerabilities list of those. After that, we can turn on Dependabot. And with Dependabot, we can get some automatic updates. So we can get notification for vulnerabilities, but we can also get updates for both vulnerabilities and versions. And the last part of securing your supply chain is dependency review, which is an action that we can use in GitHub that will block pull requests. And in that case, you can actually prevent introducing vulnerable dependencies to your code. And why is this important? Well, there are some reviews been done, and over 80% of the code that we deploy to our servers are actually open source or packages that has been coded by somebody else. And we don't actually know how good their processes are. When we look at the code part, we have two distinct parts of scannings. The first one is secrets. And what GitHub Advanced Security does is for every commit, you can actually make sure you don't leak any secrets, any tokens, any connection strings, and so on and so forth. And this is also one thing that you can extend and add your own patterns as well. And another thing is code scanning. And this is static code analysis that you can implement in your code. And in many cases, it's as simple as a couple of clicks. And for this tool, we are using CodeQL, which is a free tool that can be used by others as well. For protecting other things, we have some ways of working protection. So we have branch protection, making sure that we have pull requests, duality principle of just reviewing our code. And this is one of the basic things probably everybody should have. Then we have a commit signing, that means that we can enforce requirements that all commits are signed. And then we have also security overview. And with security overview in GitHub, we can actually see how many vulnerabilities do we have? Are there any specific packages we usually use that are vulnerable? Is there anything else like we can see on the larger scale? So with that, I would like to jump into demo. Right, my screen is still visible. So as every good TV chef, I prepared a repository for us where we can have where I have a couple of things. So I have a backend code made in C#. I have a front-end code made in JavaScript or TypeScript. I have Terraform scripts for both AWS and Azure. And also backend is containerized. So it's a Docker container. And with that, I just made one pull request or just one commit to this code. And with this, I would like to turn GitHub security on. So for my organization, this is already turned on in some ways, but now I will show you how you can actually continue on that. So first of all, I have already dependency graph enabled, and this is a requirement for Dependabot to work. So if I was to actually close this, I will get warning that Dependabot and the Dependabot security updates will be disabled as well. And I don't want that. And other than that, I can enable Dependabot alerts. And also I can enable Dependabot security updates. The last part here is Dependabot version updates, and I will need to configure that to actually get it to work. Because I have enabled dependency graph, dependency security updates and alerts, I can already here see on my security tab that I have 4 package vulnerabilities. So this is the list of packages found. There are some that are NPM and one that is a NuGet package dependency. And I can see here which package ecosystem it is. This is also something that I can filter on. So I can filter on the packages I have. It's two dependencies on JSON5 here. I can filter on ecosystem as well. I can clear my filters and so on and so forth. If I open vulnerability, I will see details about it. And what is great with this thing is actually it is to the point. So it describes impact, it describes problem, you have some mitigation, and you have a details about how to actually solve this. And also you have some information of which versions are affected and which version are patched. So basically to get this to work, so to resolve this vulnerability, I need to update my package from 1.1, 1.01 to 1.02. For vulnerabilities where Dependabot managed to open a pull request, I will see this button as well. And if I press it, I will be taken to pull request page when I will see the pull request that Dependabot opened for me. And the same thing, if I go here, I can see that I have two pull requests, and it's the same what I can see in this screen. We have pull request 1 and pull request 2. So back to pull requests, and let's open this one. In this case, Dependabot realized that it can help me with this update. So it created a version update for me. So if I look to file change, right now it's a lock.json and a bit messy, but if I take the diff here, I can see the change it did. So I can see here it's 223 instead of 221. And if I go back to content, I have some information here. Release notes, change log, commits, and so on. There is another thing here I can see, it's compability number. And this is one of my favorite features, which basically tells me how it generates number based on how many open source community projects that did this update, how good confidence it is that it doesn't break the CI/CD build, it doesn't break your builds. So in this case, I have a number of 87%, and that's pretty good number in most of the cases. Still, you would need to do some testing to make sure that nothing changes in your code. If I'm happy with this, then I can just do merge. And what I will see now, pull request is closed. I can see that Dependabot communicates that with me. And right now, I can see if I go to security, I can see that I have 2 closed and 2 open. If I look at a specific vulnerability, and if I do a review and maybe make sure that, okay, this is just a dev dependency, or this is something that I don't find critical, I can actually dismiss this alert. And when I dismiss alert, I need to enter a reason for it. So one reason is the fix has already been started. I don't have bandwidth to fix this, risk is tolerable, and so on. There are some alternatives. Let's say I choose no bandwidth to fix this. I put some comment, and I dismiss this alert. When I with this in mind, now the alert is dismissed. It's not visible here anymore, and I have the history here. What happened with my comment, who did it, and when. If I go back to the Dependabot alerts, important thing to know is that I can actually select and go back to the closed vulnerabilities, and I can go in and reopen them at any time. So they don't disappear. I can just make sure I'm dismiss them for a certain time period. So these are Dependabot features, vulnerability updates, and also warnings here, alerts. For Dependabot to work, we needed to have dependency graph enabled. And how I can see that, or I can review that, is to go to Insights tab, then choose Dependency Graph. And this is my dependency graph here for the project. So I have one vulnerability left for this project. I have dependency, the dependencies, other dependencies, I don't have any vulnerabilities, but I can see everything listed. And just to kind of go through how much dependency we have, if I take my front end, and this is almost pure boilerplate code, if I start drilling down, you can see how many dependency and how many different packages we are using, and so on and so forth. For each one of those, there is a potential risk that we include a code that will make our site, our product, insecure. All right, so that is with the updates. Now I would like to actually get help with updating versions as well. And for that, I need to enable dependable version updates. If I press enable here, Dependabot will actually get a version. It will generate boilerplate for me. And what I need is list all package ecosystems. I need to input the directory where to scan, schedule, and interval. And there is, if we go to GitHub, to the link provide, there is a lot of other configuration you can do. You can choose to prefix your branches, prefix your comments. You can change maximum number of pull requests to open to reduce noise and so on. So in this case, I will do npm, and I will just commit this file as it is. And now the scan will be done, and I will be getting pull request if this is correctly configured. Now, if you look at my project, I selected root folder, but there is nothing there. There's no package manifest. There's nothing to the Dependabot can update my versions. And this may happen to you if you turn this on. So you need to understand how to actually debug it. And how I do this is go to Insight, go to Dependency Graph, and go to Dependabot. And right here, you can see npm, but something is wrong. If I open this up, it will tell me that it cannot find package.json where I have pointed it to do. All right, so I will change that. So if I go to code again, to GitHub, I see GitHub Dependabot YAML. And if I change this, I have this prepared, so I don't need to input it manually. Just a second here. Which means I will put a package ecosystem for every single dependency and every single folder I have. And this is what I have right now. So let me edit this. This is how it looks like then. I have 2 Terraform folders that I need to scan. I have a Docker for backend. I have a NuGet for backend as well. And I have npm for frontend. So if I do this change now and commit changes, I can go back to Insights, go back to the dependency graph, and go back to Dependabot. And right now, it will actually accept it and it will tell me that it's checking everything now. When the check is run, I will be able to see pull requests coming in for those versions. There it is. So we have nlog from 300 to 511. That's a significant jump. I don't have any compability score here, and I may need to decide here if I want to update to this version or not. In case I want to communicate with the Dependabot, I can go here, open in the comment, and select one of following ways to respond. So I want to ignore this major version. So if I do that and just input it as a comment, I have now told Dependabot to actually close this without updating, and Dependabot has actually closed this pull request. Cool. And you can see here, because I have so many different package managers, every single one of them will try to open up to 5 pull requests. All right. So that's dependency scanning. So that's dependency protection, how to protect our supply chain. Let's go and configure other parts of security as well. So GitHub Advanced Security needs to be enabled. And this is free for open source projects. But if you enable this in the private repository, you will need to have a license for it. And with this, I need to configure code scanning. I need to also include code secret scanning. So let's start with the secret scanning. And with this, I have a couple of, I think it's 100 or so patterns already supplied. And they will scan every Git commit, also the history if you try to commit one of the secrets into code. And there is a difference how this works. In open source repositories, the secret scanning will run regex, and if it recognize pattern, and if GitHub has a partnership with the provider, they will send this the pattern and the key to actually provider, where provider can verify if this is a valid key, and then provider can either revoke it or notify you about this breach. For the private repository, this is not the case. So GitHub will never send your secret to provider. This is responsibility of you to actually handle the secrets internally. With this, I have a possibility to add 100 patterns locally and 500 on organizational level. So let's create the pattern, just custom one, and let's search for sign-in. So just sign in here and sign in. Let's say that needs to be in a number between 0 and 9 and 3 letters. With this, I can add patterns for before secret and after secret, and some extra requirements that I can chain in if I need to find anything particular. In this case, this is fine by me. To actually save this and dry run, I need to input a test string, no matches. Now I have one match. All right, so it works. So let's save and do a dry run. And because my project is pretty fresh, there will be no matches. So publish pattern, in this case, the pattern is active and it will start scanning. And with this, if I go back to my code, just open whichever file I want, I can then input string, secret, and do commit change. And what I will see soon is that it will be visible in secret scanning here. Perfect. In this case, I can choose to resolve it, or I can choose to close it, or to resolve it, revoke it, or whatever. In this case, let's say it's false positive and I close the alert. I can still reopen it. And this is for my own secret here that I have. As you can see, for this one particular, I didn't enable push protection, but that's also a possibility. So if I enable push protection, what GitHub will do is it will block my commit. So that's secret scanning. And let's go back and look at the code scanning part as well. Now, static code analysis traditionally in many projects, it could be daunting thing. You need to configure certain tools. You need to make sure they are they are running correctly, make sure that you're integrating everything in CI/CD and so on. And after that, you have this up and running. And with CodeQL, and CodeQL is a language that we use to actually query for instruction. So the first step, what did we do? And I can show you by creating this CodeQL analysis. And I can do that if in code scanning, setup, and advanced. In this case, I will get boilerplate. And interesting part with this boilerplate, it will actually detect languages that I use, and it will kind of create the build with everything I need. So in this case, the first thing I need to do is make sure I have, I'm initiating CodeQL. And with that step, what I do is I'm building database with all instructions with the flow of your code. And when I have this database in place, I can then write queries or run queries, query analysis to perform analysis or static code analysis of my code. To get this to work for the languages that require builds, we need to trigger auto build, or we need to build the code. And there is a GitHub action here that we can use that's called auto build. And in many cases, it will build out of the box. So C# and JavaScript for me. But if you have projects that use Java or Python or C++, this is also this can be also used. So let's do commit with straight boilerplate code that has been provided. And the first thing I will see here, if I go to actions, is that I have a queue build. I have two jobs. The first one is to analyze C#, and the second one is to analyze JavaScript. So while we wait, is there any question from the chat, Magnus or Matthias?
No, not at the moment. So I think you're doing good.
Great, happy to
But
hear.
again, any questions, just use the chat.
Yeah. As I mentioned, well, what we will see soon is that JavaScript will return first, and then the C# will continue to run. So in this case, you can see right now the CodeQL analysis is performed, and we see the number of CodeQL or query files or queries run against it. When we configure CodeQL out of the box, we're using default set of queries, but this can be changed. So because CodeQL is open source, there is a lot of community effort, and there are a lot of community queries that are written and shared. So when we run this, I can choose to run out of the box packages that are provided by GitHub. I can choose to then add community packages that are provided by open source community. And then I can add another layer of my own queries that I've custom written for my organization and adapted. All right, so in this case, we have JavaScript analysis done. And if we go to security, it looks, actually, it looks good. So nothing weird here. But in this code, C# part, I have a backend, and I have controller here that's called bad controller. And right here, I have a question. I have a controller that will take an input and will return this, will take the ID and then query something in it. Right now it's commented out, but what I will do next is I will include this as something I'm using. So if I go and edit this file, straight up here. I will and commit it. What I've actually done now, I have introduced SQL injection vulnerability. I have ID, and I'm passing this ID straight to a database query. And for that to finish, we need to let this this run, and afterwards I will go back to that. So this is part of part where we use static code analysis. We have secret scanning and so on. And in many cases, what I've seen is that we or teams are afraid of going one step further. So for me, let's go back to presentation, and I will revisit this when it's run to the end. So now we have static code analysis. We have protected our supply chain. We have secret scanning in place. And next natural step is to try and include dynamic security analysis tools. And this is for some teams or some developers huge threshold. They think it's really complicated. They think it's something that requires a lot of knowledge. And what we have here is a tool from OWASP called Zap, or Zap Attack Proxy, which is a really simple tool that we use to identify identify vulnerabilities in our code, in our deployed code, or the code that we can run queries against. Also open source, and it's great complement to GitHub Advanced Security. And I will now show how to configure this tool and add it to a pipeline or to an action. But first, if you've never seen it, and this is how it looks, it's a tool written in Java. And when I start it, I can select to do a manual explore or automated scan. So automated scan, I input which URL to scan and press attack. Pretty dramatic. And it will run a spider. It will try to figure out all the pages and run a set of scans against it. And this can be extended, this can be configured. There's so much to do with this tool. What I want to do in this session is remove the blocker. So, and it found 11 alerts, couple of medium ones, and a couple of low and information. And for every warning, it will actually tells you which pages, and you can open up and look at the risk and confidence and so on. And this tool can be run as a container, and there are provided GitHub Actions that let us run this. But for that, let's see if we have action finished, and we have. And if we go to security, code scanning, I have SQL rejection here found. I can show the path. I have everything here that I need to do, that I need to actually fix understand the problem and fix it. So for me to resolve this, I need to commit the code or dismiss it, or create an issue and do this a bit later. So I will create one issue now. With this, I want to add another automatization. And just for simplicity of the demo, I will create a new YAML file and turn GitHub, turn this on Zap on that project. Just a second here. let's call it. And because this is OWASP project, there is already an action that will allow me for a baseline scan. There are some values to configure. You can, with this tool, scan containers that are not yet deployed. That needs a bit more configuration. You can configure this tool. You can choose which version of this this tool to use, if it's a weekly or just real or stable release. But the only thing I must provide is a target. And for me, let's say I did static code analysis, I did a deployment, and as a last step, I want to do and run Zap against it. Yeah, I need to name my file. To commit, and right now I can see that I have another action here as well. So once again, GitHub. I wrote it in a wrong folder. Let me fix this. GitHub workflows and add file. Create new file. So this is a basic. And if I go back to actions, I can now see my Zap action, and this action is just workflow dispatch, so I can run it like this. Now we have Zap running. It's called let this run, and as I mentioned, this is a container running with a baseline scan. With this run, we will obviously get some results, and with those results, we can configure this so we can get this into issues. So it will, with this GitHub action, it will publish a report as an issue to GitHub here. So that's it. This is the scary step a lot of developers are afraid to take. Now, this is really basic, and the purpose is mostly to remove the blocker. And with this tool, there is a lot of that. There is a lot of configuration. You can tweak what kind of actions you want to take with it as well. But in this case, I want to showcase how easy it can be to include this in your regular workflow. So if we go back to PowerPoints. If you want to learn more, what you can do is go and look Introduction to to Secure DevOps. You can read more about static analyzers at the links, and always also you can look at the OWASP and dynamic analyzers. And also, I want to also mention one thing, and there is a new version of Zap with the plugin that can generate serif format. And with that serif format, you can actually send that file in there. Because it's only in weekly build, I didn't manage to test it yet. I will do so, and when I do, I will post a post on LinkedIn. So if you want to see how to configure that and post it to GitHub Advanced Security and get it everything visible in one place, you can check our LinkedIn. All right, so issues. I have two issues now. I have Zap scan baseline report, and I can see the issues here, what the Zap found. Pretty simple, and of course, just a start, you can do much more with a tool like this. That it is for the agenda for today. Do we have any questions?
Yeah,
Maybe
thanks,
you can take
Sanjin.
that.
Yeah, I mean, there's been a few, but I think we answered them in the chat. One that might require a little bit more context is that Azure asked about or reflected on that there are a lot of tools in a DevOps tool chain or in a DevSecOps tool chain, and I suggested that, or personally, I would look first at the integrated tools in the development platform I use, and then add what might not be there. I don't know, Sanin, if you have any other comments to how to go about this possibly overwhelming set of tools.
I agree with that. Now, the good thing with GitHub Advanced Security is so well integrated, and as we have some input here in the chat, every tool you introduce to your chain needs to be maintained. And with something like this, it's introduced. It's one part of your IDE. So of course you can add a lot of tools to this, but then you need to have understanding that this needs to be maintained, of course.
And if you don't maintain them, that will be a security risk in itself.
Exactly. And it's nothing more scarier than insecure security software.
But then again, I mean, we do this in steps, right? So we would start with the most important tools first, and then we get used to those. We get the practices around them, including how we maintain them, and then we can add the next set of tools. So yeah, take it a piece at a time.
Right.
So we got one more question, I see. Let's see what it was from P-Sedge.
Right.
Maybe it's not so much, maybe just a comment.
Let's see.
Initially, it makes sense to roll tools out in monitoring / soft fail modes. What advice would you give for moving to blocking mode as an organization security posture matures?
Ooh,
So from monitoring to blocking.
Yeah, that's that's question everywhere. It depends on maturity of your team. It depends also on what type of software you produce. For many teams, blocking can be really counterproductive. It can block and kind of create a lot of burden for the teams. So I think it's always a good idea to start with monitoring, and then as you mature as a team, then you can try and turn it as a blocking and see what happens. If you want to do it on organizational level, I would say it really depends what kind of software are you writing. If you've done threat modeling, and this is something you should do, based on the results, you need to have those actions in place. So if you have really a software that you really need to secure, then that might be an idea.
And I think you should start small. I mean, turning out like GitHub Advanced Security, for example, for an entire organization might gives you many warnings and errors and blockers. So start small and pick a repository or two or a project or two to learn the tool and decide on some practices from within your company. And then you go bigger from there. That's how I would start anyway. And from some tooling, maybe just analyze new code that is written and just ignore old code for starters. And then when you feel more comfortable, start analyzing old code as well.
Right. So if you turn static code analysis tool or dynamic to legacy code that you didn't do those checks before, you will get probably can get a lot of issues or warnings. In that case, there is a strategy where you keep clean instead of get clean, so to say, which means you try to maintain the number of vulnerabilities, and when you have this process in place, you start then removing the old ones.
We got one more question from Ali. Can you tell me the roadmap to become a DevOps expert? How about you, Matthias? Would you like to? How would you like? What would you like to say to new developers if they want to become a DevOps expert? What should they focus on?
Apart from that, I'm sure Erika will share some learning paths here in the chat. Yeah, that's a very good point. I think I would start at the core of the. I would start with the automation. So learn about CI/CD, continuous integration and delivery, and see how you use that as a platform to do more. So I think that's a good start. And then, as an expert, then you can extend that into the broader DevOps context that we talked about, to see how you would build more practices around how you develop the code, how you test the code, how you manage your environments, and then add security. So maybe it's I don't know, roughly three steps that you need to take, like the core practices around version control, CI/CD. Then you could add environment management and infrastructure as code, and then you could start exploring the security practices. And it's not like you can get away with skipping the security parts, but usually it's harder to adopt those practices if you're not familiar with the other concepts. They're kind of requiring each other's. And we can probably put a link in the chat as well. So there is a Microsoft certification called AC 400, right, Magnus?
I can put it in the chat. 1 moment.
The certification is called DevOps Expert, but it's a really nice certification because it asks you a lot of different types of questions across quite a broad set of different tools. So study for that exam, then you will also learn a lot of different practices around DevOps. Okay.
Now it's actually almost 7 o'clock, at least Central European time.
So I guess we won't hold you any longer, but let's see if Erika wants to wrap up.
Yes, hello. Thank you so much, guys, for this stream today. And for everybody out there, I don't want to be on camera because I've been sick. So yeah, you just see a beautiful red screen right now. But yeah, thank you so much for being here, and for everybody else. Just so you know, in March, we are going to do a 4-part series on GitHub as well, with Magnus, Matthias, and I believe Sanjin, you're also going to be in one of the streams, right?
That's right. That's right.
Yeah, so I will publish those events on our Meetup and Reactor website soon, sometime this week, once I catch up with all the admin. But yeah, I will see you very soon again, and thanks one more time to be here.
Great, thank you everyone, and thanks for attending.
Yeah.
And thanks for good questions as well.
Indeed.
Yeah.
Yep.
Thank you all.
Thank you.
Bye.
Bye.